Bismillahirrahmanirrahim. Assalamu alaikum everyone. My name is Muhammad Hassan and the topic of my presentation is Ferrimagnetism and the Antiferromagnetism. The key point of my presentation is Ferrimagnetism, structure of magnetite, Antiferromagnetism, structure of hematite, and the last one is assignment for the students. Ferrimagnetism. Ferrimagnetic substances are those in which number of magnetic moments vectors align in the parallel and the antiparallel is unequal. It means that the magnetic moment of one direction is not equal to the magnetic moment of the another. For example, the magnetic moment of the one side is 2, then the other side will be 3, 4, but it not should be the same. Hence, same value of the has some value of the net magnetic moment. The compounds which show the antiferromagnetism are Fe3O4 and ferrates having general formula M+2 Fe3O4, where M+2 is the bivalent metal such as magnesium +2, copper +2 and zinc +2. Here is the pictorial representation of the ferrimagnetism substance in which the magnetic moment of the one side is not equal to the magnetic moment of the another side. One is upward, second is downward, and third is also upward. Ferrimagnetism. In ionic compounds such as oxides, more complex form of the magnetic ordering can occur as a result of the crystal structure. One type of magnetic ordering is called ferrimagnetism. A simple representation of the magnetic spin in a ferromagnetic oxidation is shown in the previous slide. Two magnetic sublattices called A and B separated by the oxygen. Basically, the sublattices that is A and B are the sublattices of the compound Fe3O4, which we will explain in the next slide. The exchange interactions are mediated by the oxygen and ions. In this compound, oxygen will act as an ion. Interactions are called indirect or the super exchange interaction. The strongest interactions result in the anti-parallel alignment of the spin between the A and the B sublattices. The magnetic moment of the A and the B sublattices are not equal and result in a net magnetic moment. Hallmarks of the ferromagnetic behavior. Number 1, spontaneous magnetization, Curie temperature, hysteresis, and the remanence. However, ferro and the ferrimagnets have very different magnetic ordering. It means that one will have some value of the magnetic moment and other will have 0. Crystal structure of the magnetite. Magnetite is the well-known ferrimagnetic material. Indeed, magnetite was considered a ferromagnet. Néel in the 1940s provided the theoretical framework for understanding ferrimagnetism. Here is the structure representation of the magnetite, in which we use 3 circles. The circle which is blank is oxygen, and the circle which is black is the tetrahedral iron A side, and the structure which is grey, it is octahedral iron B side. Basically, in this compound, 2 sublattices are formed, that is A and the B. The A is tetrahedral iron and the B is the octahedral. Here is the inner view of the structure of the magnetite, which shows that the sublattice A is tetrahedral. In tetrahedral compound, the 4 atoms are attached with the central atom, while in case of octahedral, 6 atoms are attached to become a octahedral structure. Now, the second topic of our presentation is antiferromagnetism. Number of magnetic moment vectors aligned in one direction is equal to the number of magnetic moments in the opposite direction. In this phenomena, the magnetic moments are exactly 0. It means the magnetic moment in one direction will be equal to the other. For example, the magnetic moment is one direction is 3, other also has 3. 3 minus 3 answer will be the 0. The examples are V2O3, Cr2O3, manganese oxide, iron oxide, Fe2O3, cobalt oxide, CO3O4, nickel oxide, cupric acetate monohydrate. If A and B sublattices moments are exactly equal but opposite, the net magnetic moment will be the 0. This type of magnetic ordering is called the antiferromagnetism. The clue to antiferromagnetism is the behavior of the susceptibility above a critical temperature. This critical temperature is the Néel temperature. which is represented by a symbol T, and Néel temperature is that temperature above which an antiferromagnetic material become a paramagnetic. Means after that temperature its magnetic behavior will be a change, because the thermal energy destroys the microscopic magnetic ordering within the material. Here is the graphical representation of the Néel temperature. This graph has plotted between the susceptibility and the Néel temperature. On x-axis we take the Néel temperature, on y-axis we take the magnetic susceptibility. The dotted line in the graph is shown the magnetic susceptibility before the Néel temperature, but after that Néel temperature the curve is going down, which shows the decreasing the magnetic behavior with the temperature. Crystal structure of the hematite. Hematite is also a magnetic compound which shows the different phenomena with the change in temperature. In the left structure, the temperature is greater than -10. In the right structure, the temperature is less than -10 degrees Celsius. Here is the magnetic moment direction with the hexagonal structure. In the left structure, the hexagonal structure and the magnetic moment are in the same direction, means they are parallel. But when the temperature is less than -10 degrees Celsius, in the right structure, the magnetic moment and the hexagonal structure are not in the same plane, but they are perpendicular to each other, and it will show the different phenomena than the other structure. Above -10 degrees Celsius it will be slightly canted, but below -10 degrees Celsius it will be no canting. Thus this spin flow transition is called the Morin transition. Effect of temperature. It is also a graph which shows the relation with the temperature. In this graph, on x-axis we take temperature, but y-axis a quantity delta S in the units am square per kilogram is the saturation magnetization at the room temperature. The quantity that is taken on the y-axis is the saturation magnetization at the room temperature. It also shows that first the temperature will increase, the magnetization also increase, but after Curie temperature it will become down and the magnetic behavior will become the paramagnetic. Corundum structure. Hematite crystallized in the corundum structure with oxygen ion in the hexagonal closed pack framework. The magnetic moment of the iron plus 3 ions are ferromagnetic coupled within the specific C planes, but antiferromagnetically coupled between the planes. The difference is that in the ferromagnetically it is coupled within the specific C plane, but while in antiferromagnetic it is between the planes. It is the representation of the Canted Antiferromagnetism. We show that two things that have the same direction but at the different angles. Here the first arrow is at different direction and the number 2 arrow is at the different angle and show the slightly different direction. Morin transition. A spin flow transition antiferromagnetic ordering perpendicular to the C axis to be aligned parallel to the C axis below the Morin transition. What is the Morin transition? Morin transition is that transition that depend upon the temperature, and when we change the temperature the magnetic behavior will change. This is called the Morin transition. The Morin transition temperature for iron plus 3 in alpha Fe2O3 is 260 Kelvin. A change in magnetic property takes place at the Morin transition temperature. Ferrofluid. Antiferromagnetism is the rare of the two bulk behavior. It is found most in chromium and in iron manganese alloy. In case of the antiferromagnetism, the number of opposing signs do not balance, resulting in a net magnetization in the one direction. The most common ferrimagnetic material is Fe3O4, the mixed oxidation state of iron plus 2 and the iron oxide, in which iron is present in the plus 3 form. What are the ferroliquid? Those liquids that are attracted to the magnetic field. The collide iron oxide particles within the bulk liquid are attracted into the magnetic field. A ferrofluid can be simply prepared. We can prepare it by the reaction of iron 3 and iron 2 colloids with the aqueous ammonia, and surfactants are added to prevent the oxide from coagulating and the settling down. It is the reaction of the preparation of the ferrofluid in which iron plus 2 and iron plus 3 colloids react with the ammonia and the ferrofluid will be prepared. It is the assignment for the students. Number 1, what is the Morin transition? Number 2, what is Canted Antiferromagnetism? Thank you so much for your listening, and don't forget to like and comment our video.